The pyramids of Giza were built with a precision that defies modern engineering. This video uncovers the hidden engineering secrets of ancient temples, revealing how master builders achieved the impossible. You will learn the forgotten principles that allowed civilizations to construct monuments we still cannot fully replicate. How did they move 1,000-ton stones? And why did they encode celestial patterns into their foundations? What does it truly mean to build for eternity? Angkor Wat sprawls across the jungle, a city of stone so vast it defies belief. Machu Picchu clings to a mountain ridge, its granite blocks fitting together so perfectly that not even a blade of grass can grow between them. These are not just old buildings, they are testaments to a forgotten age of genius. Ancient engineering marvels share a sacred trinity of traits: longevity that scoffs at the centuries, precision that rivals our best modern tools, and a use of materials that seems to belong to a future era, not the distant past. Archaeologists like Dr. John R. Hale point to a complex understanding of mathematics, astronomy, and physics embedded in these sites, principles we are only just beginning to decipher. The core of their mystery lies in specific, breathtaking techniques. Think of the megalithic stones, cut with such accuracy that they needed no mortar. Consider the perfect alignments with solstices and star patterns, turning entire temples into celestial calendars. And then there is the seismic resilience, the way structures like those Incan walls, with their interlocking stones, have danced through earthquakes for hundreds of years while modern concrete crumbles. This was not merely construction, it was a dialogue with the cosmos and the earth itself. Why would a culture pour generations of labor and its entire wealth into such monumental projects? The answer lies in understanding that these temples were the ultimate expression of a civilization's spirit, a fusion of faith, knowledge, and an unwavering desire to build something that would whisper their story across the millennia. To unravel their secrets, we must first look at the very stuff they were made from, the stones that should have been impossible to move. High in the Bolivian Andes, the stones of Puma Punku lie in a state of elegant chaos. These are not crude blocks but shattered pieces of a forgotten technology. Each one is a geometric puzzle, featuring razor-sharp edges and complex notches that look as though they were shaped by a machine. The material itself is a profound part of the mystery, crafted from andesite and diorite, stones of immense hardness. Some of these finished pieces weigh over 100 tons. Yet the surfaces are so perfectly smooth and the corners so precisely square that you cannot slide a razor blade between the joints. This is a level of exactitude that should not exist here. Modern engineers know that working stone this hard requires diamond-tipped tools and computer-guided machinery. At Puma Punku, there is no evidence of either. So how was it done? The clues are carved into the stone itself. You can see perfectly straight grooves running along the surfaces, as if made by a giant milling machine. There are also drilled holes that are perfectly cylindrical and uniform in depth. These are not the marks of chisels and hammers. They suggest a process of fabrication, a system for mass-producing these intricate stone components so they could be assembled into a larger, grander structure. Archaeologists like Arthur Posnansky studied the site for decades, proposing that the builders possessed knowledge and tooling that simply does not fit our current historical timeline. The absence of any discovered tools only deepens the enigma. We are left with the results but not the method. This leads to an even more baffling question. How do you move 100-ton stones with such precision in a culture that, as far as we know, had not even discovered the wheel? The logistics are staggering. This impossible precision points to something far greater than simple construction. It reveals a sophisticated, perhaps even obsessive, understanding of mathematics and geometry. The perfect 90-degree angles and the repeating geometric patterns are a language of numbers frozen in stone. They were not just building walls, they were assembling a concept, a physical theorem whose principles we have yet to fully grasp. The stones of Puma Punku stand as a direct challenge to our narrative of human progress, forcing us to wonder what other forms of genius have been lost to time. And if they could manipulate stone with such godlike authority, what other forces of nature did they learn to command? This question draws our eyes from the high Andes to the very stars they so carefully watched. That same obsession with precision reveals itself in a different, equally vital form across the Mediterranean. While the stones of Puma Punku demonstrate a mastery over form, the temples of ancient Greece and Rome showcase a genius for survival. They were built not just to be beautiful, but to endure the very wrath of the earth. The Parthenon has stood atop the Acropolis for 2,500 years, a silent witness to countless earthquakes that have toppled modern cities around it. Its longevity is no accident. Ancient engineers embedded a profound secret within its majestic form, a hidden flexibility that allowed it to dance with the tremors rather than fight them. They understood something fundamental about dynamic load management, a concept we are still refining today. Look closely at its construction, and you will find no rigid, brittle connections. Instead, the massive marble blocks were often joined with metal clamps, but these were set in lead-lined grooves. Lead is a remarkably pliable metal, acting as a shock absorber that allows the stone to shift and settle during a quake without shattering. Even the columns themselves are engineered illusions. They are not perfectly straight but have a subtle, outward swelling in the middle and a slight inward tilt. This curvature, almost imperceptible to the eye, creates a structure that wants to compress under stress, becoming stronger, not weaker. At the Temple of Apollo at Bassi, this principle was taken even further. Its unique inner chamber, or cella, was designed with a series of engaged columns and strategic supports that created a complex web for distributing seismic force. The entire building works as a single, integrated system to channel energy away from its most vulnerable points. Modern researchers like David George point to the use of wooden beams within stone foundations, another brilliant tactic. The wood provides a cushion, a layer that can flex and absorb movement, preventing catastrophic cracks from racing up through the walls. Today, we use complex computer models and synthetic rubber isolators to achieve similar effects in skyscrapers. Yet, the ancient builders did it with geometry, intuition, and a deep, empirical knowledge of their materials. They were not just stacking stones, they were in a dialogue with the forces of the planet. They listened to the earth and learned how to yield just enough to never break. This mastery over movement and material forces us to ask an even more basic question. How did they acquire such perfect stone in the first place? And more importantly, how did they move these colossal weights across impossible distances? Deep beneath the island of Malta lies a sanctuary of silence that speaks in vibrations. The Hypogeum of Hale is not just a temple carved from solid rock, it is a monumental instrument. Step inside its labyrinthine chambers, and you enter a world where architecture and acoustics are one. The very stone seems to listen. A whisper uttered in one specific room can travel with perfect clarity across the entire underground complex, defying the logic of distance and stone. This is not a happy accident of geology. Every curve of the wall, every angle of the ceiling, and the very density of the limestone were meticulously carved to control sound itself. Researchers like Dr. Paolo De Bertollis have measured these spaces, discovering that certain chambers are tuned to amplify specific frequencies, particularly those within the range of the human voice. When these frequencies are produced, they do not just get louder, they create a standing wave, a resonance that fills the space and can be felt physically in the body. The builders were not merely digging rooms, they were engineering resonance. They possessed a working knowledge of wave interference, understanding how sound reflects, amplifies, and cancels out. This allowed them to design a space where ritual chanting or drumming could be transformed into an overwhelming, immersive experience. Modern acoustic engineers can design concert halls with similar properties, but they rely on computer modeling and synthetic materials. The Hypogeum was achieved through an intimate, hands-on understanding of stone and its interaction with vibration. Attempts to build new structures with such pure, targeted acoustics often fail without the nuanced, hand-carved adjustments that these ancient artisans made instinctively. Why would a Neolithic culture prioritize sound to this extraordinary degree? The answer may lie in the purpose of the space itself. The Hypogeum was also a resting place, a sanctuary of deep spiritual significance. The use of resonant frequencies could have been intended to alter states of consciousness, to facilitate healing, or to connect the living with the memory of those who had passed. It represents a holistic vision of engineering, where the goal was not just to build a structure that would last, but to create an experience that would transform those within it. This mastery over the invisible force of sound reveals a civilization that saw the world as an interconnected web of energy, and if they could so precisely tune their temples to the vibrations of the earth, it is no surprise that they also sought to align them with the grandest symphony of all, the silent, perfect motion of the heavens. The sun's first light on the shortest day of the year did not simply fall upon Karnak Temple. It was choreographed. At the winter solstice, a beam of light would travel the entire length of the temple's main axis, a path over 600 feet long, to ignite the inner sanctuary in a blaze of calculated glory. This was not a lucky guess, it was celestial engineering on a monumental scale. Every major temple in ancient Egypt was a mirror of the heavens, its foundation laid upon an invisible grid of astronomical observation. Egyptologists like Dr. Mark Lehner have shown that the builders used what we call star clocks, meticulously tracking the transit of specific stars like Sirius across the night sky to determine true north and south with astonishing accuracy. They were not just building toward the horizon, they were aligning with the cosmos itself. The columns, often carved to resemble papyrus and lotus, were not merely decorative. Their placement and the spacing between the pillars were calculated to create specific patterns of light and shadow that shifted with the seasons. A corridor would be plunged into shadow for 11 months of the year, only to be perfectly illuminated on the one day that marked the birth of a new cycle or the rise of the Nile's life-giving waters. This fusion of the practical and the spiritual was absolute. The temple was a machine for harnessing cosmic order, a place where the rhythm of the gods was made visible to all. Modern astronomers can only admire the precision, achieved without a single telescope or written mathematical formula we would recognize today. The consistency across generations of construction is perhaps the greatest mystery. A project like Karnak was built, expanded, and refined over 2,000 years. How did a priest in the time of Ramses II know exactly how to orient a new pylon gate to maintain an alignment established a millennium before? The answer lies in a sacred and oral tradition, a body of knowledge passed down through generations of priest architects who saw their work not as a job, but as a perpetual duty to maintain Mat, the fundamental order of the universe. This deep, ingrained need to synchronize with the stars was not unique to the Nile Valley. It echoes across the world, revealing a shared human impulse to build clocks from stone and to find our place in the vast, silent machinery of the night sky. A single man in Florida accomplished what modern machinery would struggle with. Edward Leedskalnin spent 28 years working mostly alone and often under the cover of night to build his coral castle. He quarried and positioned over 1,100 tons of oolite limestone, with the largest blocks weighing an astonishing 30 tons each. Witnesses who claimed to have seen him work said he moved these colossal stones with an unsettling ease, as if they were made of polystyrene foam. When asked how he did it, he would only give a cryptic smile and say he understood the laws of weight and leverage, that he had rediscovered the building secret of the ancient pyramid makers. He left behind no blueprints, no journals filled with complex equations, just the monumental sculpture garden itself. Modern engineers who have studied the site are left profoundly puzzled. They can see the results, but the method remains completely obscure. How could one man, using only simple tools like chains, tripods, and old car parts, achieve such a feat? The sheer physics of it defies our conventional understanding. Leedskalnin himself hinted at something far more profound than simple pulleys. He spoke frequently of magnetism and the secrets of perpetual motion. He claimed to have perceived the individual magnets within every atom of matter and learned how to manipulate them. This has led to theories that he might have discovered a form of acoustic levitation, using precise sound frequencies to cancel out the weight of the stone, or that he had found a way to alter the local magnetic field, effectively making the blocks easier to move. These ideas, while they sound like science fiction, echo the very mysteries we see at Puma Punku and the Great Pyramid, where the movement of megaliths seems to defy the tools available to their builders. Coral Castle stands as a powerful, modern anecdote that the genius of the ancients may not be entirely lost, just forgotten. It forces us to ask what other fundamental principles of energy and matter remain hidden in plain sight, waiting for someone to look at the world with a different kind of understanding. If one man in the 20th century could tap into this knowledge, what does that tell us about the thousands of master builders who came before him? Their legacy may not be just in the stones they left behind, but in the silent, untapped potential of the natural world around us. Mohenjo-Daro rises from the plains of the Indus Valley, not with pyramids, but with something perhaps more revolutionary, a city built for the people. Here, the greatest wonder was not a temple pointing to the stars, but the intricate network of channels flowing beneath the streets, a circulatory system of pure water, and waste that hummed with quiet intelligence. This was hydraulic engineering on a scale that would not be seen again for thousands of years. Every home had its own bathing area, and the streets were lined with covered drains, each carefully constructed from standardized kiln-fired bricks. These bricks were not just uniform in size for ease of building, they were engineered to be waterproof, a testament to a deep understanding of material science that prevented erosion and ensured the city's skeleton would endure. Archaeologists like Jonathan Mark Kenoyer have shown that the entire system was a masterpiece of gradient calculation. The builders used gravity with a physicist's precision, designing channels with just the right slope to keep water moving efficiently, preventing stagnation and the health challenges that came with it. They built great reservoirs to store precious rainwater and a complex grid of channels that managed flow for both sanitation and agriculture. This was not merely advanced for its time. Its efficiency in managing a community's well-being surpassed many contemporary civilizations and even rivals some modern municipal setups. It forces a profound question: why has this foundational level of intelligent water management, so clearly achieved in antiquity, not been a consistent reality for every modern developing community? The answer is not a simple one, touching on resources, priorities, and the complex challenges of modern urbanization. But at its heart, The story of Mohenjo-Daro is one of a civilization that placed public health and collective welfare at the very center of its architectural identity. Their genius was not just in moving water, but in valuing it, in creating a living environment where cleanliness and order were woven into the fabric of daily life. This expertise points to a culture that saw infrastructure as sacred, a material innovation that truly served the people. Such a sophisticated use of brick and mortar makes you wonder what other material secrets they held, and how they managed to create such lasting bonds from simple earth and fire. High above the city of Cusco, the stones of Saxehuaman are locked together in a titanic embrace. But the true secret to their incredible stability lies not just in the stone, but in the metal that flows between them. Connecting these colossal blocks are mysterious metal clamps, a brilliant solution to the constant threat of earthquakes. The builders carved precise channels into the tops of adjoining stones, then poured a molten, bronze-like alloy directly into these custom-shaped molds. As the metal cooled, it solidified into a rigid, unbreakable bond that locked the blocks together without a speck of mortar. This was not a simple glue, it was an integrated structural system. The resulting joint allowed the entire wall to flex and shift as a single, unified mass during seismic activity, dissipating the energy that would otherwise shatter rigid, brittle construction. Modern metallurgical analysis of these clamps reveals a level of sophistication that is startling. The alloy was not a standard bronze, but a specific composition, likely including arsenic or other elements, intentionally engineered for maximum tensile strength and resistance to corrosion. This was not a lucky guess, it was a tailored recipe for a specific, demanding job. Researchers like Jean-Pierre Protzen have tried to understand the practical logistics of this feat. To pour metal on this scale, high on a mountainside, the builders would have needed portable forges capable of reaching and maintaining extremely high temperatures. They would have had to transport the raw ore or pre-alloyed metal up the steep slopes, and then execute the pour with perfect timing and control to prevent the stone from cracking under the thermal shock. Modern attempts to recreate this often fail to achieve the same seamless integration, either producing weaker bonds or requiring far more complex equipment and fuel than would have been available. How did they achieve such metallurgical precision in the open air with the technology of their time? This was more than just advanced metalworking, it was a holistic form of material science. The stonemasons and the metalworkers were not separate trades, they were collaborators in a single grand vision. The stone was prepared with the metal in mind, and the metal was formulated for the specific stone. This seamless integration of different materials to create a composite structure stronger than the sum of its parts is a principle at the very heart of modern engineering. We see it in steel-reinforced concrete and carbon fiber composites. At Saxehuaman, they achieved it centuries ago with rock and molten alloy. Such a sophisticated understanding of materials forces a final, fundamental question, one that has lingered since we first looked upon these impossible walls. If they could fuse stone with metal on a mountainside, how did they possibly get those stones up there in the first place? The stone of the pregnant woman at Baalbek is a monument to a question. This single block of limestone weighs over 1,000 tons, a mass so immense it would challenge our most powerful modern cranes. Its journey began in a quarry nearly a mile away, a trek that seems to defy every law of practical logistics. Moving such a colossus was not a matter of simple force but of orchestrated genius. Theories proposed by engineers like Dr. Robert Heggie paint a picture of staggering effort. Imagine teams of hundreds, perhaps thousands, of workers maneuvering the stone onto a massive wooden sled. This sled would then glide over a track of lubricated wooden rollers, a process requiring constant coordination, where the rollers from the back were continuously moved to the front. The path itself would have been a carefully constructed causeway, hardened and leveled to bear the unbelievable weight. Water or some other slick substance would have been poured constantly to reduce friction, turning the ground into a muddy slipway. Yet even this detailed model feels incomplete. The sheer physics of initiating movement for a 1,000-ton block, of preventing the wooden rollers from splintering into dust under the pressure, presents problems that no modern experiment has fully solved. This leads to a deeper mystery, one of purpose. Why choose such an overwhelming stone? The effort is so disproportionate to the result that it must have been about more than just building a foundation. It was a statement. Using a single, impossible block demonstrated a civilization's absolute mastery over its environment, its resources, and its people. It projected power and divine favor in a language that anyone could understand. The very act of moving the stone was as important as the stone itself, a ritual of capability that cemented the authority and spiritual vision of its creators. This monumental effort on the ground forces our gaze upward to the next impossible step. Once they had moved these giants, how did they possibly lift them into place? Raising a 100-ton needle of granite into the perfect vertical was a high-stakes ballet of physics and faith. Ancient Egyptian reliefs depict this breathtaking act, showing teams of workers using little more than ropes, earth ramps, and a pit filled with sand. The obelisk would be maneuvered over the pit, its base resting on a pivot point. Then, with painstaking slowness, workers would begin to remove the sand from below. As the sand drained away, the colossal stone would begin to tilt, its descent controlled by teams hauling on ropes from multiple directions. This was not a matter of brute force, but of exquisite coordination and a deep, intuitive understanding of leverage and center of gravity. A single misstep, a rope snapping or a pivot point failing, would mean the catastrophic fracture of a monument that had already traveled hundreds of miles. Egyptologists such as Dieter Arnold have studied these scenes for decades, creating detailed models that outline every step. Yet modern attempts to replicate the process consistently run into trouble. The obelisk can become unstable during the critical transition, wobbling dangerously or threatening to splinter under its own immense weight. This gap between theory and practice points to a missing piece of knowledge, a subtle trick of the trade that was passed from master to apprentice but never carved into the walls. How did they achieve such a consistent, near-perfect success rate? The answer lies in a culture of empirical engineering, where generations of builders refined their techniques through observation and hands-on experience. They knew the exact moment to tighten a specific rope, they understood how the density of the sand affected the rate of descent, and they could feel the shift in balance as the stone inched toward the sky. This was applied physics of the highest order, performed without a single written equation. The obelisks themselves are a testament to this mastery. Quarried as single, flawless pieces of red granite, they were then transported on barges down the Nile, a logistical nightmare we still struggle to comprehend. Their erection was the final, triumphant act, a public demonstration of a civilization's harmony with the fundamental laws of the natural world. This profound understanding of balance and leverage did not exist in a vacuum. It was part of a larger, more mysterious system of knowledge, one that expressed itself not only in moving mountains but in the sacred, perfect shapes they chose to build with. Even a structure of perfect marble can play tricks on the human eye. The Parthenon steps are not the rigid, flat plains they appear to be from a distance. They curve upward ever so slightly in the center, an intentional bow that counters the way our vision would otherwise perceive them as sagging under the immense weight of the temple. This was the beginning of a deep geometric secret, a language of curves and ratios written in stone. Every single element of the building was subjected to this refined optical correction. The majestic columns do not stand perfectly straight. They tilt inward just a fraction of a degree, and they possess a gentle swelling at their center, a subtle bulge known as encompasses. From a distance, these deviations vanish, and the columns appear as straight and powerful as they were meant to be. Without these calculated imperfections, the entire structure would have looked distorted and clumsy to someone standing on the ground below. This was not a decorative whim. It was a profound understanding of human perception integrated directly into the engineering. The guiding principle behind this visual harmony was a sacred number, the golden ratio. This mathematical proportion, found throughout nature in the spiral of a nautilus shell or the arrangement of sunflower seeds, was employed in the Parthenon's very dimensions. The ratio of its length to its height, the spacing of the columns, even the relationship of smaller elements to larger ones, all resonate with this same harmonious ratio. Modern architectural giants like Le Corbusier looked upon the Parthenon with awe, seeing in its lines a perfection of form that he later tried to encode into his own modernist principles. Yet to achieve this today requires painstaking hand calculation and adjustment, a level of artisan care that stands in stark contrast to our world of standardized mass production. The marble itself was cut with such flawless precision that the joints between the massive blocks are almost invisible. This tight fit did more than just please the eye. It eliminated pockets where water could collect and freeze, and it created a monolithic strength that has helped the temple endure for millennia. Why pour such incredible effort into aesthetic refinements for a functional temple? The answer lies in a philosophy where beauty and structure were seen as one and the same. To these builders, a temple was not merely a shelter for a deity. It was a physical manifestation of cosmic order. A perfectly straight line was a concept of the mind, not the eye, and so they engineered their reality to bridge that gap. This sacred mathematics was not just about creating a beautiful building. It was about building a true representation of a harmonious universe, a perfect thought frozen in stone. Within the Brihadiswara temple, you are not just walking through a building, you are navigating a cosmic diagram. Every single measurement from the foundation to the tip of its soaring tower is a deliberate act of sacred mathematics. The ancient architects worked from texts known as the Shilpa Shastras, manuals that specified every proportion not as a matter of aesthetics, but as a spiritual imperative. The temple's layout is a mandala, a geometric representation of the universe brought to life in stone. This ensures the structure is not merely a place of worship, but a perfect model of cosmic order itself. The central tower, the Vimana, is a masterpiece of this philosophy. It does not simply rise, it ascends in a series of meticulously calculated, progressively smaller tiers. This visual effect draws the eye and the spirit upward, creating a tangible pathway from the earthly realm toward the heavens. Modern research by scholars like Dr. G.J.V. Prasad confirms that this graceful taper is not just symbolic, it is brilliantly functional. The diminishing tiers effectively manage the structure's center of gravity and distribute wind pressure in a way that has allowed these temples to stand for 1,000 years. Attempting to build such a temple today with only blueprints and engineering software would miss the essential ingredient, the cultural and spiritual consciousness that guided every cut and every angle. This was a holistic practice where the mason's hand was guided by a deep, devotional understanding of the universe's underlying harmony. How could such complex geometric formulas be transmitted so faithfully across a vast subcontinent for centuries? The answer lies in a unified system of knowledge, a shared language of form and number that was considered as sacred as any scripture. When we see the same principles of harmonic proportion appear in the Parthenon's golden ratio and the Hindu temple's mandala, we are witnessing a profound pattern, a shared human intuition that the secrets of the cosmos are written in the language of mathematics, waiting to be built. The silent giants of Easter Island stand with their backs to the sea, an army of stone gazing inland. Moving these colossal moai, some weighing 80 tons, across miles of rugged terrain is a puzzle that has captivated and confounded researchers for generations. The most popular theory suggests the islanders laid the statues on wooden sleds and pulled them over a path of lubricated logs. Yet experimental recreations reveal a brutal flaw. The immense weight would have quickly crushed the log rollers into splinters, creating a path of destruction, not progress. Another compelling idea, that teams walked the statues upright by rocking them from side to side with ropes, seems plausible for shorter distances. But over the island's volcanic hills and valleys, the risk of a catastrophic fall, shattering a generation's work, would have been immense. Archaeologists like Terry Hunt point to a more nuanced reality, a system combining leverage, rope technology, and the coordinated muscle of a whole community. They did not rely on a single trick, but on a deep, communal knowledge of physics and their own landscape. The mystery only deepens with the final act, the placement of the massive red stone topknots or pukao upon the heads of the erected giants. These cylinders of stone, weighing multiple tons themselves, had to be lifted dozens of feet into the air and balanced perfectly. Modern engineers have tried building earthen ramps to roll them up, a solution that feels both simple and staggeringly laborious. While these attempts can succeed on a small scale, they struggle to match the efficiency and sheer scale the Rapa Nui people achieved. This is not a story of a lost super technology, but of a refined, localized ingenuity born from isolation. Cut off from the rest of the world, they developed a unique engineering culture, one that turned immense challenges into a testament of collective will. Their success forces us to reconsider what is possible when a community's entire identity is invested in a shared, monumental goal. This profound adaptation to their remote environment makes you wonder how other ancient cultures engineered their survival in the world's most unforgiving landscapes. At Tikal, the pyramids rise from the jungle canopy like stone mountains, their steps so steep they seem to defy gravity. This dramatic incline was not an architectural flourish, but a brilliant defense against a relentless enemy, the tropical downpour. In an environment where annual rainfall could drown a city, the Maya engineered their temples to shed water with the efficiency of a leaf. The steep stairways acted as colossal gutters, channeling torrents of rain away from the vulnerable core of the structures. But the genius went far deeper than the surface. Hidden within the very plaster that coated these monuments was a chemical secret. Archaeologists like Dr. Heather McKillop have analyzed the lime plaster and found it was intentionally mixed with organic polymers, natural gums and saps from local plants. This created a waterproof, breathable coating that protected the soft limestone heart of the pyramid from erosion, a formula so effective it has endured for over 1,000 years. Modern construction in similar climates often relies on synthetic membranes and chemical sealants to achieve a fraction of this longevity, materials that can fail and leach into the environment. The Maya, by contrast, worked with the jungle, not against it, using the materials it provided to create a sustainable, integrated solution. Ventilation was another silent masterstroke. The precise alignment of doorways and the strategic placement of interior chambers were designed to capture the region's prevailing winds, creating a natural airflow that cooled the interiors and prevented the stifling humidity from settling in. The entire pyramid functioned as a passive climate control system, a stone lung breathing with the forest. This deep environmental wisdom forces a difficult question: why have we, with all our advanced technology, so often abandoned these proven, symbiotic approaches in favor of more invasive and less durable methods? The answer may lie in a fundamental difference in perspective. For the Maya, the pyramid was not an object placed upon the land, but an extension of the land itself. Its ability to withstand the rain and breathe with the wind was a physical expression of a sacred covenant with the natural world. This was engineering as a form of reverence, a dialogue with the forces of life that surrounded them. Angkor Wat unfolds across the Cambodian jungle as a perfect stone universe. Its central towers rise like the sacred peaks of Mount Meru, the mythical axis of the world, while its vast surrounding moat mirrors the primordial cosmic oceans. This is not merely a temple, it is a one-to-one scale model of the Hindu cosmos, built to bring divine order down to earth. Every single measurement and alignment in its sprawling layout is a deliberate act of symbolic encoding, a language of stone and water that speaks of creation itself. Researcher Elena Manica spent years decoding this architectural scripture, revealing how the temple's dimensions correspond to the cycles of time, from the passing of a single day to the vast 4-million-year cycle of the universe. The western entrance gate, for instance, is precisely aligned so that on the spring equinox, the sun rises directly over its pinnacle, a yearly affirmation of cosmic harmony. The galleries are lined with thousands of square meters of intricate bas-reliefs, each panel a chapter from sacred texts, depicting everything from celestial battles to scenes of daily life, all carved with a precision that suggests the hands of master artisans guided by a singular, profound vision. How did a society coordinate such a massive project while maintaining absolute symbolic consistency across generations of construction? The answer lies in a deeply ingrained cultural blueprint, a shared spiritual and intellectual framework that every architect and stone carver understood. Modern attempts to recreate such symbolically dense structures often result in hollow imitations, beautiful perhaps, but lacking the living cultural consciousness that animated every stone at Angkor Wat. This was engineering in service of a higher reality, where a wall was not just a wall, but a boundary between worlds, and a corridor was a path for both kings and gods. This profound fusion of belief and blueprints did not stop at the temple walls. It flowed directly into the design of the city that surrounded it, shaping one of the most advanced urban landscapes the ancient world had ever known. The silent grid of Teotihuacan feels less like a ruin and more like a living diagram of a cosmic idea. Striding down the Avenue of the Dead, you are walking a celestial pathway where every street and structure was placed with an intention that transcends mere urban layout. The entire city is a physical manifestation of a grand, unified theory, a perfect alignment of human society with the heavens and the earth itself. Its grid system is so precise, so methodical, that it rivals the planning of any modern metropolis. But this was achieved over 2,000 years ago by a people who left behind no written records to explain their genius. Archaeologists like Dr. George Cowgill have meticulously pieced together the story of this city, estimating its population swelled to over 100,000 individuals. Managing a community of that scale requires more than just strong leadership. It demands an almost supernatural level of social and engineering harmony. Every citizen lived in standardized apartment-style compounds, each one equipped with its own drainage system and centralized courtyard. This was not haphazard growth, it was a master plan executed with unwavering consistency, suggesting a centralized authority with a profound vision for collective living. The city's orientation is its most breathtaking secret. The pyramid bases and the main avenues are aligned to true north with a deviation of less than 1/16 of a single degree. To achieve this without magnetic compasses or telescopic equipment, the builders must have used sophisticated surveying tools, perhaps based on the painstaking tracking of star cycles over generations. They were not just plotting streets, they were anchoring their entire world to the axis of the cosmos. Modern urban planners studied Teotihuacan with a sense of awe and frustration. We can replicate the physical grid, the pipes and the roads, but we struggle to recreate the social cohesion and the shared cultural vision that made such a place possible. The city functioned for centuries as a vibrant, orderly hub of commerce, ritual, and daily life, all without the written administrative records we consider essential for civilization. What can we learn from this ancient metropolis? It teaches us that the most sustainable city design is not just about engineering efficiency, but about weaving a shared spiritual and social purpose into the very fabric of the streets. This urban mastery points to a civilization that saw no separation between the sacred and the practical, between the home and the cosmos. Such a holistic view of civilization building could only spring from a people who had also mastered the very elements they built with, leading us to ask what secrets they held in the art of transforming raw earth into a metropolis that could touch the stars. The Roman Pantheon's dome is a perfect hemisphere of concrete, a silent sky of stone that has weathered 2,000 years without a single crack to mark its age. This achievement stands in stark contrast to our own modern structures, where concrete often shows its age within mere decades. The secret lies not in the material itself, but in a forgotten recipe. Roman engineers mixed lime with a special volcanic ash called pozzolana, along with chunks of rock and rubble. When this combination met with water, it initiated a remarkable chemical process, a slow, steady reaction that actually grew stronger over centuries, especially when exposed to seawater. Modern research by scientists like Marie D. Jackson has uncovered the microscopic magic within this ancient mix. Tiny, plate-like crystals of a rare mineral called aluminum tobamorite weave through the Roman concrete, acting like a permanent, self-healing reinforcement that blocks the spread of microcracks. Our modern concrete lacks this internal structure, making it brittle and vulnerable to the elements over time. We have the knowledge to recreate the Roman formula, but we choose not to on a large scale. The process is slow and not suited to the rapid pace of contemporary construction. This reveals a fundamental trade-off in our world, a choice of immediate efficiency over legendary longevity. Why was such a powerful innovation lost for so many centuries? The fall of the empire led to a fragmentation of specialized knowledge, and the meticulous, time-consuming methods of the Roman builders gave way to faster, simpler techniques. This was more than just a durable building material. It was a pinnacle of ancient chemistry, a testament to a culture that built with the distant future in mind. The stones of an Inca wall do not simply rest against one another, they embrace. Each block is a unique individual, its edges softened and its surface subtly curved, fitting into its neighbor with such intimacy that the seam between them disappears. This was a masonry of living geometry, where the joints were not filled with mortar but with intelligence. The secret to their legendary earthquake resistance lies in this very principle. Instead of creating a rigid, monolithic structure that would crack under stress, the Inca built walls that could dance. The complex, interlocking shapes and the slight inward lean of the walls transformed seismic energy into a shifting, settling motion. The stones would momentarily separate and then settle back into place, a dynamic system that modern, rigid construction cannot replicate. But how did they achieve such impossible fits without our powered tools? Some researchers propose a fascinating possibility that the Inca possessed a knowledge of plant-based chemistry. Certain native plants contain acids that can temporarily soften the surface of granite and andesite, just enough to allow for precise shaping and polishing with simple stone tools. A stonemason could apply this extract, work the stone to a buttery smoothness, and then allow it to re-harden into a perfect, frictionless fit. Modern artisans like John Earl have attempted to recreate this process, and while they can achieve similar results, the method demands a level of patience and tactile skill that is alien to our world of power drills and laser levels. It is a slow, meditative art, a conversation between the craftsman and the stone itself. This was complemented by a profound understanding of the materials. The Inca selected specific rock types that, under immense pressure and over centuries of subtle weathering, would actually bond at a molecular level. The stones did not just sit together, they grew together. This leads to an almost unthinkable question. How did they achieve such uniformity and precision across vast construction projects without a single standard ruler or blueprint? The answer lies in a culture of embodied knowledge, where measurement was not a number on a page but a feel in the hands, and a consistency of technique passed down through generations. This was not construction by committee, but by a shared, meticulous craftsmanship that turned entire mountains into sacred architecture. Such a refined mastery over earthly stone inevitably guided their eyes upward, to the very stars they so carefully tracked with tools of equal precision. 13 stone towers march across a barren Peruvian hilltop like the vertebrae of a forgotten beast. This is Chanquillo, the oldest solar observatory in the Americas, a calendar built not of paper but of rock and horizon. From a specific viewing platform, an observer would watch the sun rise each morning, its position shifting along the spine of towers throughout the year. When it rose directly over the tower on the far left, it marked the winter solstice. As the days lengthened, its rising point would march steadily toward the tower on the far right, signaling the summer solstice. The spaces between the towers acted with the precision of a giant stone sundial, allowing a priest or a farmer to pinpoint the date within a matter of 2 or 3 days. Archaeologist Ivan Gezi and his team confirmed this function, revealing a society that had mapped the sun's entire annual journey with nothing more than careful observation and strategically placed stones. To achieve this level of accuracy required generations of patient solar tracking and a brilliant application of geometry to the natural landscape. Modern astronomers can replicate this observatory, but they require theodolites and GPS coordinates to achieve the same precise alignments that the builders of Chanquillo accomplished with their eyes, their minds, and an intimate knowledge of their own horizon. This leads to a profound question: why have we, with our advanced technology, so completely divorced our architecture from this kind of direct celestial dialogue? Our modern calendars live in our phones, abstract and disconnected from the physical world. At Chanquillo, the calendar was the world, a permanent, public timepiece that connected the community to the fundamental rhythms of life, agriculture, and ceremony. This tool-less timekeeping reveals an intuitive grasp of celestial mechanics that feels almost innate, a deep seeing that transcends the need for complex instrumentation. And just as they learned to read the silent motion of the sun, they learned to listen to the hidden vibrations of the earth, a skill that would transform their very temples into resonant instruments. Beneath the sun-baked plains of Cappadocia lies an entire world in reverse. The Derinkuyu underground city descends 18 levels into the earth, a labyrinth of tunnels, dwellings, and chapels carved from soft volcanic tuff. This was not a simple refuge, but a fully self-contained city capable of sheltering 20,000 people for months at a time. Its construction is a masterclass in subterranean engineering, a project of staggering ambition executed with flawless precision. The first challenge was stability. To carve such vast chambers from soft stone without causing catastrophic collapse required an intuitive grasp of structural physics. The builders left behind massive, strategically placed rock pillars, left naturally in place during excavation, to act as central supports holding up the weight of the world above. The corridors themselves were not random, but followed a carefully planned grid that distributed stress evenly throughout the entire complex. Modern engineers who model these spaces are struck by their inherent stability, a testament to planning so meticulous it feels prescient. Today, we would reinforce such a space with steel beams and shotcrete, but at Derinkuyu, the mountain itself was the structure. Then there was the matter of life itself, deep underground. Ventilation was provided by over 50 ingenious shafts that reached all the way to the surface. These were not mere holes, but an engineered system that utilized natural convection. Cooler, fresh air would be drawn in through one set of shafts, while warmer, stale air from the inhabited depths would rise and escape through others, creating a constant, life-giving breeze without a single moving part. Deep wells tapped directly into the groundwater provided a secure supply that could not be poisoned by besiegers on the surface, and guarding the most vulnerable points were colossal, rolling stone doors. These massive, wheel-like discs of rock could be rolled across key corridors, sealing off entire sections in an instant. Each one weighed nearly half a ton and required a precise fit within its stone groove to function. How did a society without formal blueprints or modern surveying tools coordinate such a complex, multi-generational project? The answer lies in a shared, cumulative knowledge, where each generation added to the work of the last, guided by a unified and urgent need for security. This was not just an engineering feat, it was the ultimate expression of a community investing in its own survival, carving a sanctuary of breathtaking complexity directly from the heart of the earth. Such profound subterranean ingenuity forces us to look upward once more, to consider how this same drive for permanence and meaning expressed itself not in hidden depths, but in soaring symbolic towers that aimed for the heavens. A journey through Borobudur is a walk through the cosmos itself. This colossal Buddhist monument in Indonesia rises from the earth in 9 stacked terraces, a physical mandala guiding pilgrims from the world of desire upward toward perfect enlightenment. Its very form is a spiritual map, with each level representing a stage of consciousness. The lower terraces, square in shape and adorned with nearly 3,000 intricate relief panels, depict the life of the Buddha and the laws of karma in stunning narrative detail. As you ascend, the path leads to circular terraces, where 72 perforated stupas house silent, serene Buddha statues, their forms visible through the stone lattices. This architectural shift from the square, earthly realm to the circular, formless heavens is a profound expression of sacred geometry. The entire structure is a single, unified lesson in stone, its alignments with surrounding volcanoes and celestial bodies anchoring it to both the land and the sky. Scholar Dr. John Miksic highlights a fascinating detail. The builders used a unit of measurement derived from the proportions of the human body. This meant the monument was not built on an abstract scale, but on a human one, physically embedding the pilgrim into the cosmic journey. This perfect fusion of cosmic and human scale required staggering engineering precision. The entire base had to be leveled across a natural hill, and the thousands of andesite blocks were fitted together without mortar, creating a structure flexible enough to withstand the seismic tremors and volcanic activity common to the region. Modern architects can certainly draw the plans for such a symbolic structure, but the final building often feels hollow. The integrated spiritual intent, the very consciousness that guided every carving and every alignment at Borobudur, is the ingredient that cannot be copied from a blueprint. This holistic philosophy saw no separation between the engineer, the artist, and the priest. Their work was a single act of devotion. in our specialized world, that unity of purpose has been fragmented, traded for efficiency and scale. What have we lost by separating the meaning of a building from its mathematics? Borobudur stands as a quiet challenge, a reminder that the most enduring structures are those built not just with stone, but with a soul. The Jetavanaramaya Stupa still casts a long shadow across the plains of Anuradhapura, a mountain of brick that was once among the tallest structures on Earth. Its sheer scale is humbling, yet its true secret is not in its height, but in its quiet defiance of time. For over 2,000 years, this colossal dome has endured monsoon rains and tropical sun, using nothing more than baked clay and a specially formulated plaster. The genius of its construction lies hidden beneath the surface, in a foundation of concentric layers that act like a giant, inverted chain, distributing the immense weight of the stupa evenly across the soft ground to prevent any subsidence. This was not a simple mound of earth, it was a carefully engineered system of stability. Even more remarkable is the plaster that binds it all together. Modern chemists analyzing the mix have found it includes natural organic additives like tree sap and plant extracts. These ingredients transformed a simple lime plaster into a resilient, breathable skin that repelled water and resisted cracking far better than many modern synthetic coatings. The creation of such a monument was a societal endeavor, a project that required the coordinated labor of thousands, from the brickmakers and the mixers to the artisans who applied the final coat with flawless consistency. Why have we not rediscovered and embraced these ancient, proven formulas for our own modern monuments? The answer lies not in a lack of knowledge, but in a difference of vision. The builders of Anuradhapura were not constructing for a decade or even a century. They were building for eternity, embedding their cultural and spiritual identity into a form meant to outlast kingdoms. This legacy of durable construction stands in quiet contrast to our own more transient approach, prompting a deeper reflection on what we choose to build and what we hope will remain long after we are gone. The wooden pillars of Horyujai have swayed through countless earthquakes for over 1,400 years. Their resilience is not born from rigid metal, but from a brilliant flexibility engineered entirely from wood. The entire structure is a complex puzzle of interlocking joints, each one carved with such precision that it locks into its neighbor without a single nail or drop of glue. This joinery is not a simple connection, it is a dynamic system. During a tremor, the joints are designed to shift and rock, absorbing and dissipating the violent energy that would shatter a rigid, nailed building. The wood itself breathes, expanding and contracting with the seasons, and these carefully calculated joints allow for that natural movement without compromising the temple's integrity. Modern carpenters who study these methods discover a science of wood that borders on artistry. Each cut is a deliberate decision based on a deep, generational understanding of wood grain, density, and how different species behave under stress over centuries. They learn to use woods like Japanese cypress, which possesses natural oils that repel insects and resist decay, ensuring the structure's core remains sound for generations. This knowledge, however, is not found in a textbook. It is passed from master to apprentice through years of hands-on work, a slow accumulation of tactile wisdom that teaches the feel of a perfect fit and the sound of a well-made joint. This very continuity of skill is now at risk. In our fast-paced world, the decades-long commitment required to master such a craft has few takers, and the economic realities often favor faster, cheaper construction methods. Why does this potential loss matter? Because these temples are not just buildings, they are living libraries of applied physics and material science, a testament to a sustainable way of building in harmony with natural forces. This profound respect for the material was not just a technical matter, it was a spiritual one where the very act of construction was imbued with ritual and intention. Before a single stone was laid, the ground itself was made sacred. The foundation of an ancient temple began not with a blueprint but with a ceremony. Under the watchful eyes of priests and astronomers, rituals were performed to align the site with the cosmos, often timed to a solstice sunrise or the rising of a key star. These were not empty gestures, they were the first and most critical step of construction. Offerings were made not merely as gifts to the gods, but as a form of spiritual soil testing, a way of asking the land for permission to build upon it. This profound act consecrated the site, transforming a patch of earth into a node of cosmic energy. Anthropologists like Dr. Miriam Stock point out that these ceremonies served a vital practical purpose. They forged an unbreakable community commitment to the project. When thousands of people share in a sacred vow to see a temple completed, the level of care and attention to detail becomes a matter of collective honor, not just a technical requirement. This spiritual framing ensured that every stone was laid with intention, and every measurement was checked and rechecked with a devotion that modern efficiency standards cannot replicate. How could this ritual focus have actually improved the engineering? The answer lies in the mindset it created. A worker who believes he is building a home for a deity will take infinitely more care than one who is just following a foreman's orders. The rituals established a culture of perfectionism, where a misaligned block was not just a construction error, but a spiritual offense. This multidimensional approach to creation, where belief and building were one, resulted in structures that were not only physically sound but also culturally and spiritually resonant for centuries. This same holistic vision, which saw no separation between the sacred and the practical, extended to the lifeblood of any civilization, its water. The sprawling temples of Angkor were sustained by an invisible lifeline of water. Beyond the grand moats that mirrored the cosmic oceans, the Khmer engineers constructed a vast hydraulic grid, a network of reservoirs and canals that turned the seasonal monsoon from a threat into a resource. These massive reservoirs, known as barrays, were not just pragmatic storage tanks, they were sacred oceans on Earth, reflecting the heavens and symbolizing the source of all life in Hindu cosmology. This dual purpose was the genius of the system. Every drop of water served both the body of the kingdom and its soul. Archaeologists like Dr. Damian Evans have used advanced LiDAR technology to peel back the jungle canopy, revealing the true scale of this achievement. The mapping shows a meticulously planned network that stretched for dozens of miles, a web of channels and embankments designed with a surveyor's precision. The entire system operated on gravity, with elevation changes calculated to the inch over vast distances. Water would flow from the larger barrays through a sequence of smaller holding tanks and canals, ensuring a controlled, steady supply for irrigation that could feed a metropolis of nearly 1 million people, while also preventing catastrophic flooding during the heaviest rains. Modern water management in the region often grapples with siltation, where channels clog with sediment and require constant, expensive dredging. The Khmers engineered their system to mitigate this naturally, using the flow of water itself to keep the channels clear and designing settling basins that trapped silt before it could reach the critical arteries. Why is this beautifully integrated approach not more widely implemented today? The answer often lies in the fragmentation of our modern disciplines, where engineering is separated from ecology and utility is divorced from meaning. We build efficient systems, but we rarely build them with a soul. The Khmer vision saw no such separation. The same water that grew their rice also purified their temples and connected them to the universe. This holistic mastery over a fundamental force of nature stands as a quiet challenge to our own compartmentalized science, suggesting that the most enduring solutions are those that serve both our physical needs and our deepest human longing for connection. We can simulate the construction of a pyramid with powerful computers, yet we cannot actually build one. This is the quiet paradox of modern engineering. We possess tools that would seem like magic to the ancients, from laser-guided cutting machines to cranes that can lift 1,000 tons. So why do our most ambitious replication efforts consistently fall short of the originals? The challenge is not a lack of power, but a fundamental difference in knowledge. Our science is digital and theoretical, built on equations and models. Theirs was analog and empirical, carved from generations of hands-on experience with stone, wind, and water. An engineer today can design a perfect joint on a screen, but the ancient mason knew the feel of the granite, the sound it made when struck correctly, and exactly how it would settle over the next 100 years. This intimate, tactile wisdom, passed from master to apprentice over a lifetime, is almost impossible to code into a machine. We also overlook the profound role of cultural motivation. A modern project is bound by budgets and deadlines. An ancient temple was a spiritual imperative, a project for eternity that mobilized an entire civilization's identity and faith. Workers were not merely laborers, they were participants in a sacred act. This drove a level of care and precision that our efficiency-driven economy struggles to justify. Researchers like Christopher Dunn suggest we might be missing entire chapters of their understanding, particularly concerning natural energies and the sacred geometry of the Earth itself. Perhaps they were not just building structures, but tuning them to resonate with planetary forces in ways we are only beginning to sense. The greatest barrier to rediscovery may not be technical, but philosophical. We are trying to rebuild their monuments with our mindset, and the two are worlds apart. Their legacy is a humbling reminder that some forms of genius are not stored in data, but are woven into the very spirit of a culture, leaving behind wonders that quietly question the trajectory of our own progress. Three-dimensional scanners now trace the surfaces of ancient stones, mapping every microscopic imperfection with a clarity the human eye could never achieve. These digital models reveal patterns in the joins, subtle tool marks, and stress points that tell a new story of how these structures were conceived and assembled. In laboratories, chemists are painstakingly recreating the Roman concrete recipe, not just to copy it, but to understand the nanoscale chemical reactions that give it self-healing properties. The goal is not mere replication, but comprehension, to learn the principles behind a material that grows stronger with time. This is the new frontier of archaeological science, a fusion of disciplines where astrophysicists study celestial alignments with software that can rewind the stars to their ancient positions, while materials scientists analyze metal alloys from Incan clamps to understand their precise seismic performance. At sites like Göbekli Tepe, where carved pillars predate Stonehenge by thousands of years, each layer of excavation forces a profound reconsideration of human development. Its very existence suggests that the drive to build complex, monumental structures may have been the catalyst for settled society, not the result of it. How do we reconcile a timeline that places such sophisticated engineering in an era we once considered primitive? The answer may lie not in a single breakthrough, but in a collective shift in perspective. We are learning to ask different questions, to look for the subtle interplay of geology, astronomy, and community in every carved block. Every new scan, every successful experiment, is a piece of a vast, interconnected puzzle. This evolving inquiry reminds us that the past is not a sealed book, but a living conversation. With each technological advance, we gain a new dialect with which to speak to the masters of old, and in their silent, stone replies, we may yet find the keys to building not just for our time, but for eternity. These ancient temples stand today not as ruins, but as mentors in stone. Their silent walls have shown us the impossible, from stones cut with machine-like precision to foundations that dance with earthquakes. We have witnessed a form of engineering that was never just about construction. It was a sacred dialogue between humanity and the cosmos, a fusion of science, art, and spirit that our modern world has largely fragmented. This journey challenges our very definition of progress. It asks us to look beyond the power of our tools and remember the power of our ingenuity, our patience, and our connection to the world around us. Let the legacy of these master builders inspire you to see your own world differently. How can we build things that are not just efficient, but meaningful? How can we create with an eye for eternity, not just for the next quarter? Share which of these ancient secrets left you the most amazed in the comments below, and subscribe to continue exploring the profound wonders of our past. May their timeless wisdom guide us toward a future where innovation walks hand in hand with tradition, creating a world as resilient and awe-inspiring as the temples they left behind.